Hey guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. I gotta be in a good mood. Come on, BBI. Let's get it together. We're gonna be in a good mood. We're gonna put ourselves into a good showmanship position. We're gonna be happy. Okay. The phone rang all day today. Like all day long today. All right, so what we have here is an xforce 2x8. Ta-da! And it's got Tershebers in it. Now, two 2290s drive-in, 8 2879s. There we go. There we go. Okay. So, the guy says to me, BBI. I'm like, yeah, man. What are we doing? And he says, I want you to turn that into a 16 pill. I said, yeah, man. Gonna be a lot of work. And he goes, well, what do you mean? I said, well, and I go on to explain to him what I'm going to explain to you now. See this? See this? That's not heatsink. This is copper tape or something. Or a little piece of copper that they've taped to the bottom side of this board. There's no heatsink here. So it means we have to take all of this out, mount a piece of heatsink to it, drill all this out, remove this 2-pill driver section, no big deal. Take out these caps, move the tuning tube, change the combiner, change the splitter. And then because we've got red dot Toshibas in here, it would only make sense to add 8 more. And he goes, man, I got an idea. And I said, yeah, man, what's that? Because I quoted him how much this was going to be. He's like, oh, damn. I was like, yep. He's like, that hurts. And I said, it should. Your balls should just about go up inside your man body. He goes, I've got 2 Sweet 16s with non-red dot Toshibas in them that I can send up there, and you can strip one of them down, or 2 of them down, and then out of the carcasses you can make yourself something really good, and you can sell it if you want to. And I'm like, oh shucks, thanks buddy. Yay, more work for the Texas Star expert. Yeah. No. Here's the deal. Is you envision one thing in your mind, and then reality comes forth, and reality puts you in check. So, let's go take a look for her. What do you think? We'll just start down here. So yeah, we got Toshibas. This tab, not even soldered in. That's what's left of our output combiner. Our primary combiner. This thing's had a bad day. I don't know what this glitch choke's doing here. Absolutely worthless. There's been a lot of shit over time that's been soldered and cut out. And those are from the 330 puff capacitors that are supposed to be there. At least the blow-all trace is still intact. At least the bias is still in these. So the carcass on this one is a 4 or a 5 in quality. We'll look at the faceplate, it's intact. Okay. So we have to take the whole picture in. At some point or another, this has been burned up thoroughly. And somebody deemed out there in the radio world that it wasn't worth enough energy or enough money to try and repair this by putting a couple more transistors in it for whatever reason. Here, we'll look at it from the other side too. And we'll see some other things that we didn't see from the opposite side. Like this resistor is burned up. This resistor down here is burned up. Our little 10 ohmers. These two have been replaced at some point or another. But we go on and we notice that these aren't stock resistors either. These are stock resistors. That's a stock resistor. This is an aftermarket resistor here. Aftermarket resistor, aftermarket resistor, aftermarket resistor, aftermarket resistor. All of these combiners have been burned up thoroughly. Now, I don't know what the deal is here with these two caps. I know that they did this in a few of the older ones. But there has been some serious chooch outlet out of the chotch. Okay. So we might scavenge a couple transistors out of this one. We might. We're going to find out here together. So then we come and we look at this dumpster baby. Let's start here. Do just like we did in the last video. The 330s are in there. And yeah, it's got Toshibas, sure enough. But then we start missing parts like, where's our combiner? It is not even present. There's the capacitor for it. This is a little 10 amp relay, which could be made to work. We're missing our combiner here, completely missing. And then we come and we look at this combiner. It has also seen better days. We've got two burnt resistors here, two burnt resistors here, two burnt resistors here. Sorry, come on, catch up camera. Two burnt resistors here, burnt bias reference resistor here, burnt bias reference resistor right here. This one is still intact. These two resistors down here, that one's burned. And so is that one, which we can see right there. Right there. So, burned, 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 maybe. Maybe. Burned up for sure, burned up for sure, burned up for sure, maybe. I don't know if we're going to have 8 transistors out of this group. Out of a possible 16. The ass end of this amplifier is in good condition. Where this one here, somebody took literally, they cut another piece of metal off. And then they drilled it out and fabbed it to look like the stock ass heatsink, or the stock end of the cabinet. That thing is roached out. The ass end of this one is still in stock configuration and in good shape. But then when we go to the front of the thing, we see we got extra switches and holes, and the switches are all burned up, and we got all kinds of problems. So, there we go. We've got all kinds of problems. So, I don't know. I'm on the fence. It sounded good in theory. I mean, it sounded really good in theory. Here, let's hit this button here. It sounded great in theory, but I don't know if we're going to be able to pull this off. So the first thing that we need to do is we need to pull all of our transistors and see what we have to work with. we know for a fact that these are probably garbage. We're going to pull them out anyhow because we need to open up the holes. This one here isn't even soldered in, this transistor here. I don't know. I'm on the fence. This is going to take a lot of time to get this figured out. Wish us luck. Here we go. Okay, so let's see what we got. I went through and put a little black dot on the ones that we know for sure are fried, because the 10 ohmers are completely smoked. We're going to test them anyhow. We'll see what we get. Junk. 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 See, this is the gamble. This guy probably made out like a hot bandit on these transistors. Junk. So I tell guys all the time, do not buy amplifiers off of eBay. Don't do it. Junk. 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 Hmm. 13. This one's good. Thirteen. $15. I hear 12 pill in the future. 17. $20. Prettiest one of the bunch. Well, these are all bad, and we knew they would be. So 16 transistors, and we got 2, 4, 6 good. So 10 bad transistors out of 16. Let's see what he wants to do. Almost forgot. These two little unknowniums are sent along. These amps were packed in nothing short of the guy's garbage. I mean, they were kind of wrapped up in bubble wrap. This has got a gain of 26, by the way. Kind of wrapped up in bubble wrap, but I just pulled the 2 amps out. And my guy says, hey, he was supposed to send along 2 loose transistors. So I had to go digging. I found them, though. They were in there. Gain of 41. These are good. 16 pill, I hear. Okay. This is going to be interesting. That's all I got to say. This is going to be interesting. Well, we're at that point now. We stripped off the 2-pill section. We've disconnected everything. The coax connectors, which we're going to replace, I mean, what this guy's going to pay me is, I mean, we can't do it half-ass. We'll pull that combiner out. The remote's disconnected. The ground strap, which we're going to replace, is disconnected. This is all going to stay in play. The input splitter network is disconnected. The output tuning tubes have been removed, and all the capacitors have been removed. So now what we'll do is we'll graft on another piece of copper here, copper phenolic. We'll graft that on, solder together here at this joint. We'll add another power wire, at least one. Then we'll put crossbars through here to tie the 2 together. But it has come time for us to take this out of the case and see what we have going on underneath. So let's find out. A little bit of prying, and this will come right out. Save that grommet. All right. So let's see what we got here. Normal garbage. Okay. Single-sided copper tape. All right, well, $64 million question. Is it easier to replace the power wires completely, or do we just add to what we already have? So go ahead, we'll disconnect this piece of heatsink. Then we're going to go over and see what we've got for extra stock. We should have a piece that's fairly close. Let's go see what we got. It's gonna be a long night. So, here's the deal. I've got this piece of heatsink that I took out. Plus I've got this piece of heatsink. Now I take the two, and by magic I put them together. I have exactly the same width and length of heatsink that's in there already, with the same fin width. Now I've got this piece of heatsink that's already pre-drilled and polished, and I could lay it right in there. Please note, it's just a hair shorter, and it's got a higher fin count. Now in theory, because of the higher fin count, you're going to have more heat dissipation, right? Well, that enters into the never-ending debate. Kind of like, is global warming real? Well, yes, climate change is very real. The data that people argue about on the interboob is questionable from a lot of different angles, and I'm not going to get into that. But this is the same style of argument. Technically, there's more fin count, so therefore you have more surface area, which allows you to have more heat dissipation. But what you also have here is more surface area, which equals more resistance, especially because we're in a forced aired enclosed cool loop. Okay, and what I mean by that is we're going to put air into the system, and air with the least amount of resistance has to maintain its most maximum velocity as it transits through the heatsink. This is good. This is good also. But remember, we have a wider surface area for our air to collimate, another big famous fancy word for, say, flow through, for our air to collimate through. It's got the same thickness of bed. So you have your fins, and then the bed, heatsink thickness, okay? They're roughly the same height, so that means they'll fit inside the cabinet. This would be the easier route to go, but it's not going to match what's in the box. Air is like water, and like electricity, it'll always take the path of least resistance. Okay, remember that. Give me a test on this later. So if we put a piece of heatsink like this and a piece of heatsink like this, and we put it in a square little box, and we take a fan and go woo, and we blow air and try and push it through the two surface areas, we're going to find that we're going to get a higher velocity out of this. I'm not saying this is bad. I'm just saying I want it to match. Now, because I have one of the magic machines that allows me to squish two pieces of metal together and make them into one, I'm going to go this route and completely re-drill it. That also means I've got to go through and I got to backfill all these holes, and then I've got to resand or surface or land the heatsink. And because the aluminum is actually designed to conduct heat away, it means we got to use a lot of amperage. So your mom and pop's little 100 amp welder won't do the job. It'll be stretching it. Thank God I've got a much bigger welder than that. I could do this, and we might come back to this piece of heatsink. I highly doubt it. We'll probably end up using, I got a junk piece of heatsink over here that we're going to work as our landing bed for us to mount our heatsink to. Now, I do have this here. I totally forgot I had this here. That is technically the same shit. But I'm saving this for a special project. That is why. This is going to be eventually one of the masterclass boxes. It's going to be a 2, 4, 6, 8, 10, 12 pill. But I want this extra 8 inches worth of heat sink, and then I got to build a special collimating channel or funnel for my air. It's pretty hard to get this heat sink anymore. There's still lots of places on the internet that sell it. Yes, I know. From my supplier, they don't carry this anymore. They've gone fully over to this stuff, which works and works well. Built several amplifiers out of it, like the last couple hundred, it seems like. So, at the end of the day, we're going to go with this option, just simply because I want to use my welder. So now I got to go and V this surface back. Then I got to tack the heat sinks together. Tack it up here, tack it down here, tack it, and I got to jig. I get to play with my welder. That's what makes me excited. So I'll hold on to this. Let's build something cool out of stuff that is not. That's just my opinion. Flat. Let's get back on the 16 pill here this morning. Had to come off of it for a couple days to do quite a few other projects. But, oh, for love of Pete and Pearl, come here. Oh, of course you're gonna fall off the shelf. Come on. It's okay. No amplifiers are being harmed. We're okay. It's okay. Oh, X-Force. There we go. Okay, let's see, where do we leave off here? We just finished the heatsink. Oh yeah, we're gonna mount the heatsink. Need that. Need any of this shit, so I'm going to replace all of it. I do need this. This can go away. All right. So let's see here. Laying frame this morning. Never seemed can tell anymore. All right. Do. It's gonna be tight. We'll make it fit. Just like that school date and prom. A little bit tight. For the power wires, that is. Oh, this is always a little bit of fun. Always a little bit of fun. So there's a couple little cute tricks that nobody wanted to tell me about when I first started doing all this shit. And I had to figure out the hard way. And what do I mean by hard way? Well, what do you mean by hard way there, BBI? As in snapped off drill bits and all kinds of other issues. I have a jig for this now that I had manufactured because, well, I got friends that are machinists. But the ghetto hoopy trick is first we tap out our mount points. And then the second thing I need a Toshiba. Because the HG foot's just a little bit bigger. So am I gonna be able to find a burn up Toshiba in my bag of goodies? Pretty sure. Okay, so the ghetto hoopy trick to this is take a dud transistor, take your punch, transfer. Okay? That's the ghetto hoopty trick. The other major trick has to do with alignment of the transistor mounting hole. This is key. Anybody that knows or has had the lovely experience of getting to know drilling incredibly soft aluminum like this, that it has this thing called galling. Okay? When you go to drill it, unless your drill bit's really super sharp and you got your your ripplings just right, it won't come off in chips. So if you're too fast, it turns to like smooch underneath the bit and it'll clog the bit, but it has a tendency to bite and grind, or bite and grip real hard. Well, when you're drilling that small of a hole in aluminum, you can't have any kind of torque issue going on, right? So you gotta have a drill press. If you manage to do it by hand, go out and buy a lottery ticket. Hey man, you're the shit. You got a Donkey Kong wiener, I got it, okay? The other thing is you want to make sure that your pathway underneath your transistors is clear of a fin. I struggled with that for a while. And I had a really, really good friend of mine says, you know, BBI, I used to have to struggle with that too, and then I finally figured out what it is the edge of the drill bit catching one of the edges of the heatsink fins, causing it to bind unevenly, and it's snapping a bit off. I was like, oh, well shit. It's like that moment when the light comes on, you know what I mean? Ding, light bulb above your brain. And then I had another good friend of mine, a good teacher and a mentor and a friend of mine. He come along and he taught me about this tool called the Tap-O-Matic. The Tap-O-Matic is basically a very fancy clutch. And it comes in really handy for tapping real soft aluminum, like heat sink or copper. But the clutch mechanism in it allows you to set your torque limits on your bit, and about 1 out of every 3 times, if you don't bother to lay out your pathway for your drill holes through the heatsink properly, and you do manage to catch the edge of a fin, the clutch will give before the bit breaks. But once you do that, you got to pull the bit back out and just throw it in the trash can, because it's full of micro fractures and all kinds of shit. So let me get out my jig. Now that I've marked my mounting holes, I want to verify that I'm square. It's important. Get out my jig. We'll set it for xforce pill width, because you know these are all different, right? xforce, Fat Boy, all them guys are different, right? Dave was different for a while, but now they've changed. And the staggering between the transistors, like Fat Boy set a little bit farther apart, just a hair. xforce is a little bit closer together. And then when Arlen took over, that changed a little bit too. That if you get out a set of calipers and you measure the actual pill pocket to pill pocket, that changes. There's a little bit different punch standards. Just a little bit, not a lot, a little bit. Well, the heat sink's on it. I mounted everything up, and I jigged up my holes. I drilled my holes out for my heat sink, brought it back over, realigned what I thought I was lining up straight on the heat sink, mounted or knocked in my friggin' mount points on my heat sink, and drilled them. Didn't even pay attention to where they're out on the heat sink. And now when I mounted the thing on the board, and the heat sink's cockeyed. Not by a little, but by a lot. So I'd take the heat sink off, flip it around, re-drill all the holes for the pills, and remount it. But now we're on there straight and square. We're good to go. Okay, so next step is let's build the amp section around this. Well, sorry to cut everybody off mid-sentence. That was a phone call I could not ignore. And I had to take it. I had to go take off and go deal with some shit. It pays to pay attention in this game. It also pays to hoard parts. So this is an xforce, okay? Now, let's say over the last decade of me doing this, I've got 2 or 3 xforce amplifiers that have wound up here for whatever reason, and they ended up getting turned into parts. Well, I don't keep the amps completely assembled. I strip them all apart for their parts, right? As I literally, like, here's a complete xforce input section, pre-assembled. We hold on to these things so we can do jobs like this. We have to have matching components. I cannot go and build a whole new output section over here. It won't match this output section. The type of capacitors won't be the same. The ferrite's not going to be the same. The wire size is going to be roughly the same, but I mean, there's going to be little differences. So how do we overcome that little difference? We have exactly the same parts in vintage. Now, when I mean exactly the same, let's say I've got 20 output sections for xforce. Well, over the years, the manufacturing has changed slightly. Our ferrite beads change a little bit. The way the plates are put together changes a little bit. The spacing on the plates change. For a lot of years, they cut them in half. This is a late 90s to early 2000s model xforce. Right here, I'd say early 2000s, just based off of the 1000 puff capacitors, which are made by CIMIC. Well, we happen to have right here early 2000s xforce output section with 1000 puff caps. They're made by Simic. And the exact same kind of ferrite, the same kind of plates, the same kind of cuts, the same kind of everything. Same thing with this. Each one of these capacitors has the exact same print and is the same tolerance as those. And the same thing with the 120s. For what we're going to do with this, to make it so it's even got a prayer of doing its job, we've got to make sure that we've got balance. And the only way we get balance is by having the same style of components. Our output tuning caps, exact same output tuning caps here. So we're going to endeavor to assemble this, but it's going to go really fast, okay? Versus having to spend an entire day rebuilding all of this, we're going to be able to reduce that time by having parts. Guys will send their amp here and they'll have me take the transistors out of it, and then they'll have me do something else with all the transistors, and then I'll end up buying the bulk of the amplifier back. Now, normally I don't even bother keeping a board. I got stacks of heat sinks over there, hence the reason we had a piece of heat sink that matched. Okay? Just because these two pieces, one came out of here and the other one came from another amplifier that was, well, guess what? Another 4-pill section. Put them together, you got an 8-pill section, as far as the heat sink's concerned. So, it pays to pay attention. The only variable are these transistors. Now the gains on these were fairly high and they're put in matched pairs. So the gains are matched to work with each other. That's pretty much all we need. This is one continuous 8-pill matched, same lot, non-red dot. And these are all non-red dot, even though that makes no difference. No difference. You can take the red dots and the non-red dots and intermix them. It makes no difference. So as we progress through this, we're going to have to change our output combiner network, our input splitter network. Now, how much you want to bet that I probably already got one of those? Just saying, probably like an entire tote full of them at this point, full of input and output networks. I got parts, and today I'm grateful for it, is what I'm getting at. Customers are going to be grateful too, because it's a quicker turn, but we are going to see a little bit difference in diminishing performance. Just a little bit, about 300, 400, 500 watts. But like I said, once again, once you see what the final project with this is going to be, you'll understand. I got to punch one more hole in this for a power wire, and I think I'm going to do it here, which is going to make the spacing of these odd. But I mean, I guess I could put a body plug in here, knock a hole here, and then knock another hole here, because I need 1, 2, 3, 4, 5. I actually need 6. Yeah, 1, 2, 3, 4. I need 6. I gotta have 6 wires. I gotta make it look pretty too. That's the other challenge of this. Okay, so I'm gonna put input and output network together over here, get that all soldered in, and we'll be back. It's like making a cake. So I'm back over here, I'm working on this 16-pill project. And I believe where we left off in the previous segment was I was talking about, gotta focus, because if I don't get this just right, it's gonna screw me in the long run, it's gonna look wrong. Okay. I think where I left off, because I've been just trying to work on this while being on the phone pretty much all day long today, was we were going to solder down all these parts. So I got all the output done, input all down, and then I went ahead and I switched over to getting the output network installed. And I think I explained why it's easier for me to, I'm sorry, I've just, this particular amp, I've had stretched out over a couple weeks now, as I've been doing multiple other projects interleaved with it. So it's better to, instead of me having to go and rewire and retrofit everything, we're going to use a bunch of components we already know that match, just for cost, number one, and simplicity, two. So I got all the output network of this mounted down, okay, and then I went and we're using this particular setup. So we got our combiner set up all in place now. I got the input network all built up, so it can go on and it'll match up with all the other ferrite components that are in here as well. Now what I'm working on is building the positive distribution bus down the middle of the box for the 12 volt DC. We'll bring all that, we're going to tie these as a group. So first I'll strip off these ends here. We'll solder them down to our distribution bars, which we've also shorted together. I've covered this in many, many videos, but it seems like each individual video I need to treat as its own individual satellite video and not let the knowledge be accumulative. You know, I got 14,000 plus viewers, right? 15,000 plus viewers at this point. But every video I put out gets 3,000 or 4,000 on average views. So if I share a tidbit of knowledge in one video, it doesn't necessarily mean that the end person, the average Joe, is going to see each video and put it as an accumulative thing. We have to have short buses that go between the two, a piece of wire. So behind these chokes, there's a piece of solid copper, just in case half of our power distribution network comes unplugged. There's still an ability to have current flow from distribution A to distribution B when it comes to these xforce amplifiers. I don't like doing them this way, but this is what I had to work with, and so we're going to build from that. We upgauged our wire for obvious reasons. So at the end of the day, instead of having a little 22 gauge fuse that goes here, we're going to upgrade our power wires and bring our current directly down to the transistor and have the transformer just transform, instead of also double as a current conducting device, which it doesn't hurt anything to do it that way. It just kind of snubs the circuit by 3 or 4%. So by adding its own independent distribution network, we pick up 3 or 4% worth of current distribution inside of here. Transistor doesn't have to work just as hard, and it produces just a little bit more power that way. Just a little bit more headroom. So we'll get the power wires installed. When I come back, the wires will be in, everything will be zip tied and soldered in place, and I will start with the 5 watt flyback resistors. Then we'll put 5 watts on our inputs and 5 watts on our outputs. And then this thing, for the most part, will get ready to get dropped back into a cabinet. Then it'll start looking like a whole amplifier again. Okay. So we got all our power wires in here. And we got our load cells in place. Resistors act as load cells, per se. So now we got to figure out, we're going to do another auxiliary relay over here. And because this thing is going to be used primarily in sideband, I want to use a secondary relay to key it, and that'll also give me the option to give him an aux input. So if he wants to use a foot pedal or use his amateur radio that I think he's going to end up using and use the amp key off of that, it can drive this relay. So that's what we're going to add next, is our auxiliary relay, which will drive this relay. We'll use the stock keying circuit. We're going to add our sideband delay, and I think we're going to put in our biasing circuit, actually get it wired for voltage, and then I think that's time to put it in the cabinet. So that's what we're going to work on next. We'll be back with an update here just a second, guys. Okay, so it's come time for us to put this into its case. And so what I did is I took and got rid of the little old grommets that were in here. I drilled these out and doubled them in size, because we're not only literally tripling down on the number of wire leads, we're doubling the size of the wire leads going into the deck. So kind of tinkering with the idea if I should knock these fins out to help with a little bit better airflow. It's much easier to do it when the amp's not in here, obviously, but think it'll be okay. Take a look. Yeah, it's got rubber feet on it. The only thing else I got left to do is to plug this hole up here. So, all right, let's do the awkward process of sliding this old girl up in the hole and putting her back where she needs to be. And then, of course, we're going to get rid of the, I don't even know where the old connectors are. I think I pitched them already. We're going to change out. We're going to put brand new silver-plated gold center conductor with actual real Teflon, not the fake $1.99 ones off eBay. They're like $5 a piece. Coax connectors on it for the guy. So away we go. This is my favorite part. So we're going to take this old girl, which is the first time you guys get to see this one on camera. This is my Weller. What is this thing? This is the 175 watt Weller. I just purchased this here at this last ham fest I went to. We're going to soak some heat in this thing and see if we can clean this connection up a little bit, so we can squeak a couple more amps out of it, get it to flow down to the board. It's a little bit better. Big iron. Love big soldering irons. Make short work of fun stuff. Alright, so we'll flow this down on the edge of the board a little bit. Spread our joint out. There we go. A whole lot of flux. But, God dang, that thing is a smoky son of a gun. That made short work of that. So, we are officially in like sin, man. Got our bias circuits all installed. Now, I was going to point out this tuning tube. This is a brand new one. The original one, I was planning on reusing this, but we can't. If we look here, we'll see there's a cut in the Teflon. So as you slide this down, it's going to catch on that Teflon sleeve. We can't have that. That little pinhole right there is enough for us to have catastrophic failure. So these are like $9 or $10. Doesn't really matter. Got to have something that's safe. Otherwise, all this work will be for nothing. And there has been a lot of work put into this box. But we are about 99% there. Got our switches installed. Sideband delay, new power switch installed. The old one was crap. So I think it got smashed in shipping. The only thing left I got to do is we got to figure out how to get the RF from here, or from over here to the rest of the deck. I think I have the solution. Well, here we are. Day number 4. Been working on this off and on now for a couple weeks. I'm a total of 4 days in on this one. Between the heatsink construction and all the drilling and tapping and sanding, and I don't know why. It would have been so much easier just to slap different heat sinks underneath it, and I would have been done with this days ago. But I was fixed on doing it just this one way. That, and I really did not want to take out the old xforce transformers and put mine in here. I really wanted to stick. I don't know why. I don't know why I got stuck on that either. But here we are. So the only thing I got left I need to do is trim these, hook up a ground, and play with it. That's what I'm going to do now. I've never built a box this big with sideband in it, and I probably won't do another one. I just wanted to experiment and see if it was possible. There's some tricky shit going on with control and the bias other than just these resistors that you're seeing on top. I had no place to mount them up here, so this is voltage regulated per se. So we'll see. We're going to see how well this works. I want to key it and run it and measure everything first. I'm going to key it real low. I got to get this dialed in just perfect for this guy. So when we come back, this thing will be making power. Or I'll be saying, what? It blew up. We'll see. We'll see. I have confidence, though. I think I might have the skill set. Well, here we are at the end of this story. We've got a beautiful 16 pill, and boy does it run. Over here we got the bench 2 pill. Let's move the 2 pill and the driver a little bit closer. Everybody to look at. This slug here is a 50 watter in reflect, 2 pill, and we're going to hit that with our 2950. That's it. No other secret sauce. Over here is a 1000 watt slug in 5X. Over here is a 5000 watt slug in Bird, or average, or main squared. I'm so smart, I got Google. That guy makes me laugh. Every time I say RMS now, I just laugh. This guy that got on Facebook and tried to act a fool like he knows anything, but never builds nothing. So there's a lot of people that don't do. They pretend like they do. And they got a couple little cronies that follow around. It's called a gang of idiots. And so the one gang of idiot, well, hey man, did you watch that video? Yeah, he said Bird. Or he said average. I don't care. You call that whatever you want. It's an unaltered output signal from the line coupler. Period. Over here we have an amplified signal. A peak. Or in the Bird world, CW. Doesn't matter. Okay, so amp off, driver off. Show you something. Oh. Turn on a peak kit, make sure that's off. Okay. Hello. So 20 watts of drive looks like on a 5000 watt peak slug. Hello. Okay. Let's turn this down to 1x. So we're putting about 380 watts in this amp. And we don't need much more than that. It's a solid 4,000 watts of peak power with 320 watts of drive. I totally get why guys don't build 16 pills with bias on them. Because people will overdrive the shit out of these things. If I went and I put a 1x4 into this thing, it would explode. Game over. 400-ish watts drive. Gets you 4,000 watts out. So, pardon the loud-ass fans, but when you've only got 2 of them to cool a 16 pill, and normally you'd use 4, you got to give it every chance that you can. This thing is beautiful. Absolutely beautiful. I love it. I get it now. Let's go look at our input reflect. Hello, one. About 2.5 watts. About 2.5 watts. All right, let's go to lower sideband for the shits and grins of it. One. Hear the relays chattering? We're going to engage our sideband switch. 1. 1 2 1 2. 1 2 1 2 1 2. 1 2 1 2 1 2. If they can't hear you on 35 or 3800 watts of power on sideband, you just don't have Mother Nature to talk there. That's all there is to it. This thing's been a labor of love. Now, Mr. B, I gotta tell you, man, you gotta be easy. And so I called you this morning and I told you no more than a 2-pill driving it. No more than a 2-pill driving it. So like I was saying, can't use anything more than a 2-pill. Overdrive this box. Remember, there's only 16 $200 transistors in here, getting cooled by 2 120 millimeter fans, but their pressure is kind of flowed, restrained by the slots on the top of the box. Okay? So let's keep that in mind. Let's go over here and we'll look at our spectrum analyzer real quick. The end of the analyzer is at 500 megahertz. The start of the analyzer is at 0 megahertz. And there's our second and our third order harmonics down from our principal. They are 40, 50 dBm down. It's not teabag. Ain't the greatest in the world, but it ain't teabag. It's enough for me to let it go and feel perfectly comfortable with it. Now we're blowing out some hot air out of the back end of this thing. Gotta mind the heat, brother. Remember, you got all those biasing load resistors in there, plus 16 transistors, and they're working for every little bit they got, plus 2 voltage regulator transistors. And they're just doing their job. Just in there doing their job. So, guys, at the end of the day, we're all in this hobby together. I've only got 1, maybe 2 little small things I got left that I need to do to this amp. I need to clear the inside of it to keep it from corroding, so if I ever have to come back here and work on it ever again, it'll be easy peasy. And the other thing I need to do is I need to add a switch. I'm going to put it on the back, and the switch is going to be down in the down position for internal key, and then up for auxiliary key. It's that simple. It's truly just that simple. Gentlemen, my name is BBI, and without a shadow of a doubt, I am the biggest mud duck in Idaho. Come check us out, www.bbiamps.com. Come find me on Facebook, Twitter, Snapchat, Instagram, and right here on the YouTube Porn Gargler. I can't thank you guys enough for your never-ending continued patience on all of these projects I've got over here. This guy has been waiting almost 2 years at this point to get this amplifier done. I'm doing the best I can, 1 amp at a time, as many amps as I can do a week. 6 days a week, 12 to 14 hours a day. It's no joke. Appreciate your guys' support. You guys keep your heads down out there. This coronavirus thing is starting to look really kind of serious. Remember, distance. Distance. Keep your distance from people. I see you guys. Be safe. Bump bump.